Shall I start, Srinivas?
1 minute, ma'am. 1 minute.
Okay.
Good evening, everyone, and welcome to today's YouTube live session on evolutionary algorithms and generic optimization techniques. We at the we at IEEE Computational Intelligence Society chapter of Vardhaman College of Engineering are thrilled to host this event. Over the next hour, we will be exploring how these algorithms mimic natural selection to solve complex problems. So please don't hesitate to drop your questions in the live chat as we go. Now, it's my absolute privilege to introduce our expert of the evening, Miss Kiranmaie. She's an assistant professor in the IT department of CBIT Engineering College. She is bringing valuable experience in computational intelligence, AI, and neural network domains to explain us all about it. We are incredibly fortunate to have someone with her technical background here to share her insights and mentor us today. Ma'am, thank you so much for joining us and accepting the invitation. The floor is all yours right now.
Yeah. Thank you for the introduction. Myself, Kiranmaie, assistant professor of in Department of Information Technology, CBIT. Good evening to one and all. Today, I want to discuss about the topic of evolutionary algorithms and genetic optimization techniques. In day-to-day life problems, in current recent trends, this topic is very much important because most of the practical problems do not have a direct simple answer. So whenever to implement any of the practical problems, such as even when it comes to the organizations to schedule a timetable or to find the shortest route between to your college or to your office to your particular home, there are many possible routes and there are many possible answers for the complex problems. So identifying the best one is very much important in any of the practical problems. So to go into the topics of content, I want to give first brief introduction about what is an optimization. So as we already know, optimization means it is process of finding the best possible solution to a problem. As we have seen in many of the scenarios, either for a delivery person to take the product from particular company to destination address, or even for a particular person to reach from home to the college, we require or we choose the best possible route, which includes less distance and effective way of transportation in order to deliver or in order to move from one source of place to another destination. So finding the best possible solution is called as optimization. So coming to our optimization works is it is used for particularly improving the performance and efficiency of algorithms. In our problems, in our computer science field, any of the problem is dealt with an algorithmic solution. So whenever we are writing a algorithm, obviously the best way of choosing the algorithm is how much it is efficient in terms of the time and space, right? How much it is practically implemented, the scalability of particular algorithm. So the improving the performance and particular efficiency of algorithm is the main objective of. Next one is importance of optimization. Uh, op- Optimization improves the efficiency of systems and processes. It will help in decision making and it will reduce the cost and resource. Majorly used in all the fields such as engineering, business, computer science, artificial intelligence, and whatnot, logistics also. As you can see here, we can see here it improves the efficiency of systems and processes. And the another main point of optimization is it must done as we took the same example. If we want to reach from particular house to college, so we have to choose for the best way and also the efficient means which route takes the less fuel, the cost also being mattered in that scenarios. So the optimization, one of the major point is also reducing the cost and also the resources usage and the better decision making and widely using across multiple domains. These are the some real world applications. So here I want to explain the use in real life systems. Here we can see the different examples such as route planning, scheduling, logistics, machine learning. So if we take the route planning in particularly, so when we use Google Maps, the system will check multiple possible routes, right? So whenever we enter the source and destination, it will check the multiple possible routes and it will recommend the fastest and the shortest one. So while choosing the fastest and shortest one, it is also considering the factor in which route it has the traffic or the road closures, means if there is an accident, road closure, and the traveling time between the source and destination. So optimization is not only finding the shortest or shortest path or the fastest way, but also it should also consider the factors such as if there are sudden accidents, the road is closed, and the traffic is more in this route, such things also should be considered in the optimization. So when it comes to the next real life example, scheduling, one of the example what we can take is our college timetables. Whenever we schedule a timetable, we should consider the major basic point that no two classes should clash. And also similarly, we also consider that students will get one of the free period, one of the library period, and that too those kind of periods should come in the afternoon or the last hour, not in the first immediate hour, because our productivity of brain is good at morning times. So whenever we provide the library or sports are these kind of things in of any of scheduling, we will also consider those things. That's what it comes under efficiency, right? And then next example is logistics. So when it comes to delivery companies like Amazon or Flipkart, they have to go to many places in a day. They have to deliver many packages in many places. So they can't simply choose the random routes. They have factors such as delivery, distance, cost, and also time. Important is logistics also. And the final one, the final application is machine learning. So this optimization is also important in the machine learning, because why it is used in machine learning means while we are training a model, the performance of the model is based on various parameters. So when if we include the optimization, means which parameters has to be activated and which parameters has to be included to improve the performance. There it comes the optimization into picture for the machine learning. And if we consider this optimization to train the number of, to check whether what is the learning rate or what are, how many number of layers it should be, or what are the other hyperparameters. If we consider all these factors, it will help us improve the model's accuracy and also it will reduce the manual effort. Complexity of problems. So whenever we are saying that the optimization means wherever we are dealing with the purpose of optimization, means in real practical problems we are requiring the optimization, right? So whenever we have these kind of real world problems, it will have large number of possible solutions. Means if there is only one solution or if there are only two solutions, it will be easy for the task to choose one of the solution. But whenever there are multiple solutions, there will be a confusion which solution is the best to choose for particular task. So whenever we have multiple solutions, the search of particular solution, good solution, it will become impractical. And the computation cost also will be higher. Okay. So the search becomes impractical and the computation cost is also very much more. And depending upon the particular problem, the number of variables, as we discussed, one of the application is also machine learning. So when it comes to the model performance, the number of variables, the number of hyperparameters or the learning rate we have is also more when it comes to the real life problems. So let us take one example. So if there are multiple classes and there are multiple teachers, if it is a simple of count of 3, if there are 3 classes we have to schedule and there are 3 faculty, it is easy for us to schedule because there are only 3 classes and there are only 3 members of faculty. So it is easy for us to set the timetable. But if there are 60 classes and there are 5 faculty members or 10 faculty members, there comes the picture of confusion, because there will be a room constraint, there will be hour constraint, subject constraint. So all these factors have to be considered. That is the example where it grows the exponentially with the variables. So here the number of combinations will become huge. That is the complexity of the problems. And we already have some of the traditional optimization methods. So what are these traditional optimization methods means? See, in traditional methods, there is a struggle with complex and non-linear problems. Means if it is a simple problem, obviously there will be no problem. If it is a complex or non-linear problem, it will require exact mathematical formulation. Otherwise, we will stuck with the local optimization solutions. And these local optimization solutions, here it is not efficient for large search. So this kind of traditional methods, it is useful only for the very less cases. But when it comes to the higher complex or practical problems, these traditional methods are not sufficient. As you can see here, if the local optimize here, then it is by using traditional methods, it will be sufficient to provide a solution. But whenever you are taking a real-time problems or the practical implementations, it will reach the global optima. So whenever it reaches the global optima, the finding of solutions is bit tough. Means whenever we have this global optima, the exact mathematical formulation is required. In the normal local optima, the normal or the temporary mathematical solutions is sufficient. And another advantage is it will stuck in the local optimal solutions. So it is not suitable for the large search spaces. So as there are limitations in the traditional optimization methods, there comes into the picture of evolutionary algorithms. So these evolutionary algorithms are, these are nothing but search-based optimization techniques. So this search-based optimization techniques, it is inspired from the biological evolution. So it will use the terms like variation, selection, and inheritance. And it will work with the population of solutions instead of only one solution. Means instead of developing only one solution, it will consider the population and the selection criteria and the inheritance criteria. So instead of having only one, here it will go with multiple solutions. So whenever we are going with this multiple solutions, it will improve the candidate solution over generations. Means it will not be done or implemented in the first iteration or first instance itself. So it is developed based on the instances of hierarchical way. There comes into the picture of inheritance. So here we can take the scenario for the campus placement preparations. Students usually go through the tests, practice, feedback, and based on this feedback, they'll correct themselves over the time. So by this repetitive process, their performance will be better, right? Not only preparing from the curriculum, it will not give the only particular solution. But if we consider the various factors, like if they have attended the mock test, they have practiced, and they have took the feedback, and based on the feedback they have corrected over time. So this repetitive process will improve their performance, which is more better. So this evolutionary algorithms will improve the solutions in the similar way. Means not in a correct one instance, in a repetitive circles way, it will improve the solutions in a very gradual way. Okay. So this evolutionary algorithms, it is an inspiration from nature. So this why we are considering nature is it is one of the best problem solvers. Means from nature itself we can take how it is being implemented in a natural sort of way. So in over time it improves the organisms through or organizations through adoption and the natural selection. So in nature, only not individuals are participated, the population are doing the same. Not only the individual, the candidate selection is going on through the population. So some population are stronger in population, some of the candidates are stronger, some of them are weaker, and some of them are most suitable for particular environment. So as we are considering these type of test cases, the individuals with better traits, they will survive good, and they will better to reproduce. And while with the weaker traits, the stronger ones actually they survive through it, but when it comes to the weaker ones, they gradually disappear over many generations. That the population will be getting adopted to it, and it will continue through the generations. So the evolutionary algorithms borrows the same idea. Instead of instead of going with the single one, we have a candidate. Instead of focusing on only physical strength, we also have the fitness values, computation, over selections, crossover, and mutations in the computations. This is why these algorithms are called as nature inspired. Okay. So evolutionary algorithms are inspired from the nature because it is a part of biological evolution. In biological evolution, not a single trait is required. A multiple population is required. In a multiple population, some of the candidates are stronger and some of them are weaker. So the stronger, we will take the attributes of survival and the reproductivity. And in weaker, they'll gradually disappear or they will adopt to the particular nature existence. Yes. Next one is Darwin's theory of natural selection. This is one of the important factors. It gives the biological foundation of evolutionary algorithms. So Darwin's theory of natural selection, it will explain how evolution happens through population, variation, selection, and inheritance. These are the 4 steps we have. So let us go through each term clearly. Population means we already know it is a group of individuals in a species. So here in this particular algorithm, population means it is group of possible solutions. This population means group of possible solutions, and variation means individuals which are different from each other, and selection means selecting one particular one depending upon the tasks we need, because the different solutions have different equality and different features. So this selection, particularly the fitter individuals, means the individuals who are more likely to survive and reproduce. So it will come under selection. And then inheritance, useful traits means from the stronger selection of people, whatever useful traits are there, how they are surviving and reproducing, the useful traits from the particular people will be taken and will be passed on to the next generation, so that they will be adaptive to the evolutionary algorithms by default. There comes the picture of inheritance. The useful traits are passed to the next generation. So as we can say, one of the example we can take is whenever a particular student or a person is preparing for any competitive exam, so there are multiple students, but the students with particular better preparation, they will perform better and they'll move on to the next stage. So their performance determines the progress. So in the same way, the better students who prepare better in a particular format, they are variated. Okay, the total number of students will come under population, and the better students with their better learning strategy comes under variation. And in that, we are selecting the fitter individuals that are better survive, means who are achieving something. We are selecting those people, and we are considering the traits of particular successful people, and we are passing those traits to the next generation. That is called as inheritance. Next one is representation of solutions in evolutionary algorithms. So this is a binary string. We will consider it as a binary string. So you will consider all the possible solutions here, and wherever you have the candidate solutions, you will take all the possible answers, and all those will be evaluated together. All those we are calling it as a population. And in this population, by collecting all the important traits of these people, we are creating or we are coding into a one complete encoded solution. Okay. So this particular one encoded solution is represented through a chromosome. Okay, means nothing but this representation here like selection, means from population we are taking a chromosome, means selecting a particular fitter strength. We are taking the fitter stripes and we are considering it as a chromosome. And next one is in chromosome we are moving to the smallest unit of solution, and this one represents in a form of a single parameter. This totally will combine into a chromosomes, means in chromosome the individual part of solution is called as gene. So when it comes to the genetics of the evolutionary algorithms, from a group of population, we are moving to the chromosome, means one complete solution. In that complete solution, we are taking every single parameter. Each single parameter is called as a genes. So this is how, next one is how to find the fitness function. This fitness function is good to find a solution for the given problem. It measures the quality and it will assign the score, and it is also used for selection process. So usually whenever we get a higher fitness, it will provide that means it is a better solution. Now let us go what is the important part of evolutionary algorithms, which is the fitness function. This fitness function will tell us how good or how suitable a solution is for the particular problem. Means in simpler terms, how we can say is it nothing but it is like a score for your examination. So in the evolutionary system, how particular what is particular evolutionary algorithm got, that is decided by a fitness function. So this is just to find the quality of a particular solution. Okay. So here you will consider the item number, and for that particular item number, you'll have the chromosomes values. Depending upon these chromosome values, there will be profit and weight values of each of chromosome. Okay. So first step is it will measure the quality of each solution, and then it will assign a numerical score based on the performance of each solution. And whichever solution has the highest fitness score, it will be considered as the better solution, and that will be used for guiding the selection process of the algorithm. Okay. So this is measuring the quality of each solution, then assigning the numerical value, weight values, numerical values. So whichever has the highest profit value and the weight value, that will be considered as the best solution. And next one is selection, crossover, and mutation, the basic circle of the reproduction. So initialization of population, and for each population we will calculate the fitness function as we have seen in this previous slide. So we will measure the quality of each solution, and that measuring will be done by a numerical score. So this is with fitness function, and based on the fitness function it will go to the selection, then reproduction, that is nothing but crossovers and mutations, then convergences. Yeah. So let us go each step clearly. The first step is selection. So selection means obviously the choosing of the better solution for the current population. If whatever solution has the highest fitness score, it will have a better chance to survive and will be useful over the generations. Why this selection is important means if the solution with the less value is chosen, means if it is a poor solution without any control, the algorithm or the efficiency of the algorithm is very less. So that's why the selection means based on the higher fitness value, the best algorithm is selected. So whichever has the higher fitness, it will have the higher chance of survival. Then next, it will move on to the crossover. So crossover means combining parts of two parent solutions to create the offspring. Okay, so if two of the solutions or the multiple of the solutions have the same fitness value, if we integrate that, if we combine that, it will give the better offspring. So the main idea in that is each parent will have useful features, and if we combine them properly, the child will get the much better solution because they are getting the most beautiful, most important traits of both parents. So nothing but combining the strengths of two individual candidates. And the third one is mutation. So mutation is nothing but a small changes, means it will introduce a small random change into the solution. So why this mutation is important means this will help in maintaining the diversity in the population, and also prevents the algorithm from becoming too limited. Means not only taking the features that are already there in that particular fitness score, but also making few changes and also improving it to the optima. If we go with the mutation by introducing very small random changes, it will go to the global optima. Okay. So this particularly will maintain the diversity, and by combining these three, it will create a balance. The selection will help for keeping good solutions, and the crossover will help for combining the useful traits, and the mutation in particularly helps to create the diversity and the new possibilities. Next one is genetic algorithm steps. So basically, a genetic algorithm means it starts with the random solutions, and then it will go to the evaluating the fitness, and then selecting the best ones. After selecting the best ones, it will apply the crossover and mutation and repeating this process over the generations. So why this repetition is required means this repetition will continue until a stopping condition is met. Okay, as you can see here, the numbering is already there in the steps. So the first one is initializing the populations. Each population or each candidate will develop a random solutions. So for each solution, you'll go to the fitness. So based on the fitness, we are evaluating the particular weight of each solution, and depending upon the highest fitness, we are selecting the best individuals. And for that best individuals, we are applying crossover. Crossover is nothing but combining the best traits of multiple solutions to create a offspring. And after crossover, we are applying mutation on variation. After this, we are repeating this process for the future generations. Why this? As we are selecting the highest fitness values, the weaker solutions are being eliminated and the stronger ones are only retained. So over this repetitive process, it leads to the better overall performance. So that is the essence of evolutionary process in the optimization. Okay. So we can say, take a real time scenario. While we are delivering a project in the first sprint, the project is not good. Through over the sprints, the project development will be done and it is finally handed over to the particular client. So over the sprints, we are making it better by considering the performance, and we are evaluating and we are testing the performance. The same process is also repeated in the genetic process by using the evolutionary algorithms of optimization. And this is one of the example for the genetic programming. So this genetic programming is an extension of genetic algorithm. So it evolves computer programs instead of fixed solutions. Means it will develop the random solutions instead of the fixed solutions. These solutions, as you can see here, it is represented in the form of a tree structure, and this progress will be repeated over the generations to improve the performance. So what is the goal means? It is to evolve an expression or particular logic automatically. Uh, Suppose instead of only choosing the best parameter values of the model, we want the system that automatically generate a rule of expression which is useful for the prediction. So that is where genetic program becomes useful uh, to make it better for the prediction. So as you can see here, it will start at left child node, and we are going with the root node, and then again we are taking this performance to evaluate the fitness solution of particular one. It is in the form of a tree structure. So it uses the selection. First, it is selecting the particular candidates with good traits, and then it is crossovering, means combining, and then it is making few of the changes. Okay. So how we evaluate this genetic algorithm is by using genetic programming. So this genetic programming, it will automatically generate the optimal solution or at least the near optimal progress. And the next one is applications of evolutionary algorithms. So this slide, it will introduce the broader applications of where the evolutionary algorithms are used. It is used in many problems if the intelligent and wherever the intelligent exploration is needed. So next slides, we can see the individual particular problems, but here we can see the normal domains. So wherever we particularly we are focusing on here machine learning model optimization. So in machine learning, as we discussed, evolutionary algorithm, it will choose the best parameters for the models, and these parameters can be represented as chromosomes. So model performance is evaluated using a fitness function, and the best combinations are improved over generations. So these outcomes are better accuracy and reduced manual tuning. Okay, so first you'll consider the best parameters of the model. So how this evolutionary algorithms is useful in this means, it will represent each parameter in the form of chromosomes, and then for each chromosome it will evaluate the fitness function, and based on the highest fitness it will select the best parameter combinations so that it will improve the overall accuracy over the generations. So the outcome we expected is the better accuracy than the traditional models, and the reduced manual tuning, because as it is automating, that is the option main advantage of evolutionary. So it is reducing manual tuning. And the next one is scheduling. So in scheduling, basically tasks, the people or the resources should be assigned efficiently. Each schedule is considered as one of the best solutions, and the fitness in this particular scheduling will be dependent upon the minimal conflicts and the better resource utilizations. So if there are poor schedules, the efficiency of the particular task is not good. So the poor schedules are removed, and the better schedules will come into the evolution for over the time. So you will consider the problem, that is assigning the tasks and the people or resources efficiently. So each schedule will come under as a solution, and depending upon the feedbacks and depending upon the conflicts that are arised in the each solution, we will find the fitness value, and based on the fitness value the poor schedules are being eliminated and the better schedules are coming into evolution over the time. So what is the outcome in this particular application is it will give the conflict free schedules and the better resource utilization, whether it is a normal resource or it is a people, it will give the better resource utilization. And the next application is traveling salesman problem. So in this traveling salesman problem, the goal is to visit all the cities. We already know this. So the goal is, the main objective is to visit all the cities exactly once with minimum distance. Okay. So every route will be considered as a possible solution. And the routes improve over generations according to the fitness value. So as we can see here, yes, if each route is considered as a possible solution, we will select the best route by considering the distance, by considering the time required to travel, and the cost that is required to travel. By considering all these parameters, we are choosing the best way, like this, to go it in a single way without any clumsiness by calculating the fitness value. Here the fitness will contain cost, distance, traveling time, all these factors, and based on it, the less fitness value optimization techniques will be removed, and the best fitness value is evaluated over time. And coming to it, limitations. As of now, we are not seeing the advantages or how this evolutionary algorithms and the genetic optimization techniques are used. But what are the limitations we have overall is the computational cost is very huge, and it will take multiple iterations, and also it will stuck in the suboptimal solutions. Means in some of the test cases it will stuck in the local optima rather than going to the global optima. And finally, and it will depend upon the parameter tuning. Okay, if we did not choose the parameter, because we are not selecting the solutions in your first instance or the second instance, we are doing in the performance of a circular way. Means over the time period, we are choosing best possible solutions. So when we are choosing over the the cost is required is huge, because the from the theoretical way itself we can say that it is very huge. And whenever we are selecting particular parameters for the tuning, so depending, the total performance will be based on those parameters only. If we choose the wrong parameter or any of the multiple parameters crossovers, it will lead to the obviously bad efficiency. It will come onto the weaker fitness. So although this is powerful, the evolutionary algorithms is a powerful, still we need a careful design and proper evaluation. What the example we can take here is, if we have too many candidate solutions, or if it goes through too many generations, this method will become slow. Okay, so we have to go through the generations, but to the possible limit. And whenever we are going through the too little variation, it may stop improving. Okay, so we have to know up to the variation level, and what is the proper crossover mutation crossover we need, and what is the proper mutation we need. Otherwise it will lead to a huge failure of a particular model. And to conclude this, evolutionary algorithms, this will particularly show how the major complex problems can be solved by using simple solutions, that too inspired from the nature. Okay, so by using nature means the genetics, the normal optimization techniques. So here there is a shift problem, so that is solving from exact calculation to the intelligent search and adopting to that search. Okay, so while we are adopting, this will there is a strength to handle the large and huge data sets, which is uncertain, and also it is highly useful for handling the complex search spaces. But as we discussed, it is not always perfect. There is also few of the limitations, because whenever we are not choosing the fitness value correctly, whenever we are not choosing the crossovers and mutations properly, it comes under, the system may fail. So it is not always perfect, but in our day lives, the optimization is much needed, from the very small problems to the very much big problem. So this is a very important technique that we have to learn in the artificial intelligence systems. Thank you. Thank you for listening to my presentation. I hope you got the basic idea of what is an evolutionary algorithm and the genetic optimization techniques. And if you have any doubts.
Yeah, ma'am. Yeah. Thank you, ma'am. Thank you, Kiranmaie, ma'am, for such an insightful and engaging session. Your breakdown of genetic optimization was incredibly valuable for all of us. I also want to give a special shout out to our faculty advisor, Dr. K. Nikhila, ma'am, whose continuous guidance and behind the scenes support made today's event possible. Finally, thank you to everyone in this audience for tuning in and participating. Have a great evening, and we'll see you at the next IEEE event. Thank you.
Thank you, ma'am.